Hello and welcome back to the Jolly Ranchers YouTube channel. I am a solo developer working on a game called Kid Detective, and if you like this channel, go wishlist it on Steam. But this week we are going over how to make a physics-based game like Angry Birds without having to code at all using a plugin in Unity called Fungus. It's amazing. I do all my videos on it. It's great to work in Unity. So this is random and I just decided to do it because it was fun. So enjoy.
Okay, let's check out the demo. As you can see, we have a nice white box here, and we have some balls that fell to the ground. And you can see when we click somewhere on the screen, the ball will move towards it. And the farther away we click, blammo, the faster it'll go straight down, blam. Ground pound, slam. So, this is just a very basic thing that we will learn to do today using only Fungus to do it. Only one block is making this happen. Can you believe it? So, let's learn how to do this with the other ball, using the other mouse button as a demonstration. So what I did is I went, right-clicked, I said 2D object sprite, because this is just a game object that comes with a sprite renderer. How lovely. Then I clicked over there on that dot and I typed in square because a white square either comes with Unity or comes with the Fungus package already. I don't really know which one, but I always have my trusty square. I always use my trusty square. So what we need on it, I clicked add component, and I am going to type in box collider 2D. And that's going to make it so that physics objects can interact with the ground that we're going to make. I'm going to move it down here. I'm going to click this square button over here so that I can change its dimensions. Ooh. Ah. And I'll just make it that big so it fills out the edges of the screen. And I am going to call this ground. And I'll probably just duplicate this. Ground number 1, I'm going to drag over here and pull up to the top of the screen. And I'll duplicate it again and do this 2 more times to make a little box so that our balls don't fly away. Okay, so I have done this, and I'm just gonna child these grounds under the first ground so that I can keep all of the ground in one spot. And all that these balls are was I right-clicked, I made a 2D object, a sprite 2D object. I right-clicked on this circle over here, and I typed in circle, and I clicked on circle. If you don't have these sprites, you can easily just go into Microsoft Paint and export a PNG. But you probably do if you downloaded Fungus. Or you can use a coffee cup. What do I know? So I made it a circle. I added a circle collider by going down here, pressing add component, and I started typing in circle collider. And I added it, and because it's a circle already, it automatically, if we press the edit collider button, we can see this green circle better, and if we click on these points, we can change. This is the exact same as the box collider, by the way. But as you can see, if we change the points to be wrong, and if we said reset, then voila, it snaps back exactly to the dimensions of our circle. So you really just have to add the thing. You don't have to edit the collider at all for any of these objects, unless you have a fancier object with more zigs and zags. But that's how you would edit the collider of that object. And then I went and added a rigid body 2D, and I didn't change a single thing about this. You could, for instance, turn off gravity. Let's go see what that does. It's a simple change, but Now this is a we have one ball that has gravity and one ball that doesn't. And now it's a game of air hockey. It really is amazing when you mess around with these rigid body settings. I can unmaximize my game view and we can mess around with some more. So if I increase the mass, it's probably going to move around a lot slower because it's a heavy little circle. And you can increase the linear and angular drag, which I'm going to be honest, I have no idea what it is, but let's crank it up, baby. Let's go. Oh, it has some real friction going on. There's a whole lot of friction going on. So just, mess with these settings, and they won't save when you are in play mode. So if I pressed play right now, they would not follow me. But you can say copy component, and when I go out of play mode, and oh, I forgot what mass I set it to, it was 10. But I can say paste component values, and it changes to what I had it as in the play mode. So that's just a little tip coming your way, hot and fresh out the kitchen. So I'm going to go ahead and set it back to what the default values are. And so that's what the balls are, nothing more. Just a circle collider, a rigid body, and a sprite renderer with a circle sprite. So let us produce a new block in a new flowchart so we can just walk this through straight up from the beginning. So let's create another flowchart, and we'll call this flowchart ball number 2. Because you totally need separate flowcharts for this. I don't know. I'm not judging how you organize your game. Okay, and let's step into our ball number 2 flowchart. So the first thing we want to do is we want to have this block execute when we click the left mouse button, or the right mouse button in this case. So I'm going to change it to a input key pressed execute on event. And it's going to execute when I click the mouse down, as opposed to when I release the mouse, which would be key up. So that's a sort of decision for you. In Angry Birds, for instance, you click the mouse to start dragging it back, and then when you key up, the Angry Bird releases. So that's how you would do something like that. You would have a key down block that, drew the little loopedy line to show where the ball was going to go and have you drag the slingshot back. And then on your key up block, you would launch like we will do. But we're going to go ahead and put in the mouse key code, which is all the way past all 26 letters. And there we go. Mouse 0 is left clicking and mouse 1 is right clicking. So I'm going to do mouse 1 because I already have my mouse 0 ball, my left clicking ball. Okay, so this block is going to execute when we press mouse 1, the right click. But it's not going to do anything because we haven't put any commands in this block. So first thing we're going to do is we're going to get the position of our mouse, because we need to know the position of our mouse in order to tell the ball where to go. So we are going to use this world position field, and the world position field wants a vector 3 variable, which, if you watched my last video, you may remember this variable. This is the new version 3.13.7 of Fungus, so it's got a lot more variables, by the way. So I am sorry about that. I left out a lot of those. My bad. So we're going to use a vector 3, and I'm going to call this mouse pause for mouse position. And as you can see, when I click on this, it registers that I have a vector 3 variable for it, which is nice. Now, a vector 3 variable is an XYZ coordinate, and we're using a 2D game, so we don't need the Z coordinate. And so, the first thing we're going to want to do is we're going to want to convert it to a vector 2, which is a 2D coordinate. So I am going to make a vector 2 variable, and I am going to name it mouse pause 2D. So this is the position of our mouse in 2D space, and I am going to go over here and I will convert our mouse position vector 3, and I will convert it to mouse position 2D. Okay, so now we have the position of our mouse in 2-dimensional space. We're also going to need the position of the ball, because if the ball is here and we click over here, we don't want it to act like the ball is still where it started and launch it that way, even though it's all the way over here, and it's just going to keep getting launched into this wall. So every game object has something called a transform, which holds its position, rotation, and scale. Its position is its vector 3 coordinate, the x, y, and z coordinate of where it is in Unity space. You may note that we changed the scale of our squares earlier, and that information is held in the transform component. So we want to get the transform information from ball number 2, because we need to track where it is. So I'm going to go into our handy commands, and I am going to go to property transform, and we want to get the position of ball number 2. You can just drag it right in there, or you can click this thing on the right side of the screen and pull up whatever game object you want to get the transform data from. You'll note we can get the rotation, we can get the scale of the object, we can get a lot of things from the transform, which is juicy and nice. And we are going to want to save this in a variable as well. So we're gonna make another vector 3, and we are going to call it ball position, but just POS, because lazy. And I'm going to save it in the ball position variable. So let's just press play and see these variables fill up when we click the mouse. There are the variables, they're all 0, and then I click the mouse. Oh, that was the other mouse button, lol, and we click the mouse. Aha! And as you can see, the ball is rolling. Let's see if I can get it back to roll the other way. No, this ball is really heavy now. You can see the ball position has changed, and is changing again. Wow. So we are keeping track of this ball, and where it is, and where our mouse is. That's awesome. So just like the other one, we are going to want to convert this ball position vector 3 to a vector 2. So I'm going to press this button to duplicate this command. I'm going to drag it down under here, because we won't have any vector 3 to convert to a vector 2 if we do this command before we get the vector 3 at all. So this means we're going to want to make a ball position 2D variable as well. There it is. And now we will have the 2D variable as well. And we, as you may dread by now, we are going to create another vector 2 variable, and we are going to call this distance. And what this variable will do is it's going to save the distance in a vector 2 between the ball and our mouse position, which is how the ball that we already have working knows to launch harder when the mouse is far away and softer when the mouse is close, or to the left when my mouse is to the left of the ball, or to the right when my mouse is to the right of the ball. So this is the information we're going to save in the distance variable. Okay, so now that we have our distance vector 2, we can figure out what the heck it is. So we are going to go to set variable and then set variable to do some basic arithmetic with our two variables. So I am going to take the mouse position variable and I want to subtract the ball position variable from it, and that will be the distance between those 2 points. There we go. I clicked that thing on the right and I put up our ball position 2D variable. So now our mouse position 2D variable is the distance between the 2 points. You could skip this part, but just to make it really obvious, I'm going to set the distance variable equal to mouse position 2D. You could skip this part, or you could set the distance variable to be equal to the mouse position, and then you could say distance minus ball position 2D, and it would save it in distance, and you could skip this step. I don't know. You don't need to save the mouse position after you have it the first time. You only need it to calculate the distance. So the mouse position variable now equals the distance variable, and so you don't have the information anymore. So if you find that that's a problem in your particular instance, then don't do it this way. Okay, so very simply, the only thing that's left is to go to rigid body 2D commands and add force 2D. And we are going to add a force to a rigid body. Good thing we put a rigid body component on our ball number 2. We're going to add force and not an impulse, but you could play with that. This is all stuff you can just play with. You're not going to crash your computer unless you add like 5,000 rigid bodies. Go ahead and try it. We're going to add a force, and that force is going to be our distance variable. I know it's weird that distance can be stored in a vector too, and also be the directional force with which we launch something, but that's what's weird about vectors and why I hated math in high school. So you can change the force scale factor to make the ball launch harder or less hard. We'll do that once I make at position ball position 2D. So just go ahead and make sure that we're adding the force at the position of the rigid body. I mean, it's gonna do that anyway, but maybe I'm just paranoid that if I don't do this, it'll break. So play around with it. Okay, so let's go in and test it out. Okay, so we have our left clicking ball that already jumps around, but now we should have our right clicking ball, which, as you can see, is just barely rolling along. And that's because we can change the force scale factor to be a bit higher. I'm going to change it to 4, see what happens. Not much of a difference, but we can see it's really moving. So if yours isn't moving at first, you might want to mess with the mass and gravity of the rigid body as well as the force scale factor. So you can see with the default rigid body settings at 40 force scale factor, it's starting to jump around and roll more responsively. I'm going to up it to 100 and see if it's too crazy. No, that's not too crazy. So one thing you might want to beware of is if you crank this up to 1,000, it's probably going to clip outside of the box. Yep, there it goes. It's gone. We can track its flight far through the box. It went so fast that it was on one side of the barrier on 1 second and on the other side on the other. And that's a speed running strat for our new game of Angry Birds. Okay, so we have a Angry Bird that flies around, basically. The only thing I did to add that green tint was I used a fade sprite command, and it actually gives it a little delay before it launches. So if you find that your player can just launch infinitely and double jump and triple jump, you could use something like this or a wait command to slightly delay the launch and delay the ability to launch again for a couple seconds. Just a thought. So now, using the same techniques, we can set up a little like house for our Angry Bird to sort of break apart, and it should be incredibly easy. So I'm just going to drag the balls over here. I'll drag them so that they don't immediately roll and break the house. And I'm just going to go down here, and I am going to snag one of our sideways ground pieces and duplicate it. and I'm going to drag it so that it's its own thing. And I'm going to name it building chunk. So this is officially a chunk of a building, and we are going to need to shrink it because that's a huge building for something to knock down. I'm going to shrink it nice and small, and I'm going to duplicate it because I need another one for the house to stand up. Oh, I'm not going to duplicate it yet, and guess why? It's because I didn't add a rigid body to it. And it needs a rigid body because if it doesn't have one, it's just going to behave like the ground, and it's not going to move at all when something hits it. And we want to destroy this house with our angry ball. Don't steal the name. It's mine. And we want the building to maybe be a little sturdier than our ball because it's a building, so I'm going to increase the mass. And once you get in, you can play with how that feels. Now I'm going to duplicate it. I'm going to go ahead and drag this under the other building chunk. And I'm going to drag building chunk number 2 off to the right. I'm going to put them both closer to the ground so they don't rock around like crazy when they start. And as you can see, if you put building chunk 1 under building chunk 2, they'll move together. And if I set this to 0, if I set the Y value to 0, it'll be at the same Y value as the other building chunk, which will make, moving them around and placing them as sturdy building chunks easier for you, kid. So I'm going to duplicate the other building chunk, and I'm going to have this be the roof, and I am going to make it shaped like a roof. And if you want it to be the exact same thickness as building chunk number 1, you can copy the scale value of building chunk, the original. As you can see, it's just terrible numbers, and you might want to make these just something cleaner, at least to 2 floating point decimals. So you could copy that, but replace the Y for the X, and it would be the same dimensions as the other ones, but sideways. Okay, so let's just see how this goes. We've got a building, we've got our weapons of choice. Oh, in play mode, I didn't change the force scale factor back to this ball, so let that be a lesson to you. Things don't change during play mode. You have to change them yourself. Okay, we have our building, we have our balls. They both move around, and now let us destroy the building. Blammers. Whoa. That's crazy. I haven't done this yet, so whoa. And we knocked the house down. Now you can see strange, bizarre things are happening to these shapes as they tip over. Like one of them became sort of an elongated spaghetti monster. I don't know why that happens yet, but if you want me to find out why, I will. Tune in next time for another episode of Angry Birds Go Spaghetti.
Okay, that was a video. If you like this, please tell me what direction to take this in. Add a score or levels, a main menu, whatever. Oh, I figured out what was wrong with the collapsible building. It's that I childed some of the collapsible blocks under a main one, and children of a parent game object inherit the transform component of the parent. And so the scale was getting really warped, and the rotation was getting warped. One of the transform variables was getting really warped by the parent changing rotation and scale. So that's what it is. Don't child them. I did it. I unchilded them and it worked just fine. So if you like this type of video, please like the video, subscribe, and leave a comment telling me what you'd like to see from this, if anything. And if not, I'll continue on my merry way. Till next time, stay jolly.